In this video, I will go through the literal equations on your study guide. Okay, literal equations are those equations where there are multiple variables, okay, many different variables, and you're asked to solve for one of those variables, where we're not really getting like a solution, like a number for x. We're really just getting a whole expression for x, okay? We're going to have something on the other side. Our solution is going to be something that like can't really be simplified. It's going to look all complicated with other variables in there because our equation has more than one variable, so we can't get a real solution, okay? So here we're solving for x, and of course it's important that we pay attention to which variable we're looking for because there are two different ones. We might be solving for y. We might first be solving for x, so we have to read the directions carefully. Here it says solve for x. So I'm looking at x. I see x is getting multiplied by 3, and then this y is getting added to it. So the inverse would be to subtract y. Y minus y is 0. Subtract y on the right side as well. So I'm left with 3 multiplied by x on the left side, and on the right side I have 12 minus y. I cannot simplify that. Those are not like terms. There's a constant and a variable. I don't know what y is, so there's no way I can subtract. I just leave it. Next, I need to do the inverse of multiply by 3, and that's divide by 3. 3 divided by 3 is 1. I divide by 3 on the other side, and I'm careful to divide the whole thing. Okay, so 12 minus y all gets divided by 3. Or I can think about dividing each term. So I can think about dividing 12 by 3 and dividing y by 3. Okay, and then I'll be able to simplify a little bit because 12 divided by 3 is 4, and y divided by 3 will just stay like that. So either of those would be correct solutions. Here is another literal equation. Here we are asked to solve for y. So here we want to get rid of the x, move it to the other side, and keep the y. Okay, so I see two different things in the way. I see I have to get rid of 7 and I have to get rid of x. So I need to think about how those two things are connected to y. If I look at this, I don't see any operations. I don't see addition, subtraction, division. And I know that if I don't see any operation, it means multiply. So I can read this as 7 times x times y. So the only thing happening to y is multiplication, and it's getting multiplied by 7 as well as by x. So I want to divide both of those. The opposite of multiply by 7x would be to divide by 7x. 7x divided by 7x is 1 whole. Okay, it doesn't matter that there's x and I don't know what x is. Anytime I divide the same thing by itself, there is one group of that thing, right? That's there. Right? 7x divided by 7x is going to be 1. And then we'll divide by 7x on the right side as well. So we have y equals 14 over 7x. If you wanted to simplify that, think about dividing the top by 7 and dividing the bottom by 7. 14 divided by 7 is 2. 7 divided by 7 is 1, so that gives me 1x, okay? So this is 14 over 7x or 2 over x. Very common mistake is for students to write this as 2 times x, okay, because they do 14 divided by 7 is 2, and then they just kind of put the 2 in front of x. But be careful that if you divide it by x, the x must remain in the denominator even after you have simplified. So over here is how I simplified that and reached that answer of 2 over x. Okay, here's a different kind of problem, also literal equation, also with multiple variables. This actually has 3 variables, but that's okay. If you know the steps, then 3 variables shouldn't mess you up. Okay, now we're asked to solve for r. So now we want to keep r. Okay, now we've mentioned that you could distribute if you wanted. So you can rewrite this as 3r plus 3s. However, it's faster and simpler to do this without distributing. So we can look at r and say r is getting added to s, but I'm not going to write addition on top of there. I'm writing parentheses, okay? Because I think of going backwards of order of operations, okay? I go backwards when I undo and try to solve for one variable. So if something's in parentheses, that's going to happen at the end, okay? So r has something going on in parentheses. I'm going to save that for later. Then it's getting multiplied by 3. Okay, so all I have is multiplication and parentheses. So I'm first going to undo the multiplication, then I'll undo what's in parentheses. Opposite of multiply, divide by 3. Okay, 3 divided by 3 is 1, so I have 1 times r plus s, or just r plus s. And I will divide by 3 on the other side as well. I can't simplify that because t is a variable, so I'm just going to leave it, t over 3. Now the opposite of add s, okay, because now we have r plus s, so now we want to do the opposite of add, so we will subtract s. S minus s is 0. Subtract s on the right side, and we are done. R is equal to t over 3 minus s. And notice that we did not have to simplify anything, okay? Since we did not distribute at the beginning, we didn't have to simplify at the end. Here is another problem where we need to solve for x. Okay, solve for x. We want to keep x by itself. Now, looking at this, there are two things in the way. There's 2 and y, but if you notice, the only way that that's connected to x is with subtraction. This is actually a one-step problem. X doesn't have anything getting multiplied by it. Don't go ahead and divide by 2 because 2 is not being multiplied by x. We just look at how these things are connected to the variable that we are trying to isolate. Okay, so the only operation here connected to x is subtraction. So we're just going to add. We're going to add the whole term, plus 2y. Negative 2y plus 2y, 0. Add 2y on the other side, and we are done. Okay, x is equal to 16 plus 2y. One-step equation. We have x by itself. We accomplished what we needed to accomplish, which was to get x by itself. Okay, one last question. This one is a bit complicated. It says solve for a. 2 times a squared plus 3 times b equals 17. Okay, so what are we trying to isolate? We're trying to isolate a. Okay, so we're going to look at a, and let's see what's happening to a. Well, I see a is getting squared. That's what we call an exponent. Okay, then that's getting multiplied by 2. Okay, so multiplication. Okay, then we're adding 3b to that. I don't have to think of that 3 as multiplication, just like in the previous one, right? Because the 3 is not getting multiplied by a. So I can just look at that whole term plus 3b as addition. So it's actually just 3 things that we need to undo. Okay, so again, if we're going backwards of PEMDAS, right, we want to do that in the reverse. That's what we do when we're undoing what happened to our variable. We're trying to go backwards and isolate it. So we're going to undo the addition first, then we're going to undo multiplication, and then we'll undo the exponent. Okay, opposite of addition, subtract 3b. 3b minus 3b, 0. Great, it's canceled out. It's gone from that side of the equation. Subtract 3b on the other side. Okay, so now we're left 2 multiplied by a squared equals 17 minus 3b. Okay, now we want to undo multiplication. Opposite of multiply by 2 is divide by 2. 2 divided by 2 is 1. Divide by 2 on the right side as well. And we are just going to leave that. We are not going to try to simplify that. We don't have to say, oh, 17 divided by 2, that's 8.5. 3 divided by 2. We don't have to do that. We can just leave it like this because it's not really going to help us so much to simplify it. So it's not worth your time. Okay, so now we have a squared equals 17 minus 3b over 2. Okay, and lastly, last thing I taught you guys, how do we undo a squared? We're asking the question, what do we multiply by itself to get a squared, right? That's what we do when we're trying to get a itself, because a squared means a multiplied by a. So taking the square root is the way that we answer that question. What do we multiply by itself to get this amount? So that gets us back to a itself. We take the square root on the right as well, and it looks like a long, funky answer, but it is the correct answer. Square root 17 minus 3b over 2. That is the solution. That's how we get a isolated and get the expression that is equivalent to a.